Computers won't drive drunk. Truth or myth? Well, this one's misleading. It's a little bit of both. It may be that computers won't drive drunk, but that doesn't mean that they'll be perfect drivers. The problem is that when you remove human drivers from vehicles to make a fully autonomous vehicle, indeed, you're removing human error from the driving task because there's no person, but you're introducing robot error. Robots aren't perfect either. Here's an example from August 2023 of a robotaxi driving into wet concrete. Now, to be clear, people do this too. There's some entertaining videos on YouTube of people driving into wet concrete, and I say entertaining because people typically don't get hurt. It's just super embarrassing. So this isn't saying that humans are perfect. What it's saying is just because a human isn't there does not mean the robot won't make exactly the same mistake. In August 2023, a robotaxi had a crash with a fire truck. Now, what was happening here was the robotaxi had a green light at an intersection, but there was a fire truck in emergency response mode with its sirens going and its lights on who needed to come through the intersection, and the robot driver failed to yield as required. Now, do people make this mistake? Indeed, people do make the mistake, but the point is the robotaxi made the mistake too. So saying we're going to get rid of human error does not mean that you will have perfect driving, because robots have driving errors too. The issues with potential misbehavior go beyond traditional crash scenarios. Here's an example in March 2022 where not one but two robotaxis went through an emergency scene where there was yellow tape. You can see the yellow tape in the picture where there's some down power lines from the municipal transportation system. These lines happen to be de-energized, but if they've been energized and if there had been passengers in the vehicle, there could have been an electrocution fatality. Fortunately, there were no passengers, and fortunately the lines were de-energized. But these vehicles ran right through emergency response scene tape, dragging the tape and the wires behind it, and it wasn't just one car, a second robotaxi followed the first one through. The important point here is there are things other than crashes with other road users that are critically important for safety, and all of these things have to be accounted for. Now again, could a human driver have made this mistake? I'd like to think it would be kind of unusual for a human driver to make this mistake, but sure, it could happen. The point isn't that human drivers are perfect. The point is that robotaxis won't be perfect either. The city of San Francisco had some concerns with robotaxis from both Waymo and Cruise in 2023. They saw issues such as obstructing emergency response vehicles en route, intrusion into response zones, unpredictable operations near response zones, contact or near miss with equipment or hoses. One of them was trying to run over a fire hose, for example, and blocking the fire station by immobilizing themselves in the fire station driveway, and so on. The issues here are a little more specific to robotaxis. I'm going to say that a human driver who has a firefighter or a police officer screaming at them to move the vehicle is probably going to move the vehicle. But screaming at a robotaxi turns out doesn't work. It just sits there until a remote response unit can do something, and sometimes that involves having someone drive out to be able to move the robotaxi. The number and type of incidents created significant concern with the city of San Francisco regarding robotaxi impact on emergency response operations. Safety goes beyond just avoiding crashes. Here's a scenario from August 2023. In this case, a robotaxi was making a left turn rather than going straight through, and the road happened to be closed. Halfway through the left turn, it stopped, and then noticed it was aligned with an open lane in the road closure and decided to go through anyway. You can see there's a flag holder there in a high-vis vest. There's some road closed signs. There's some do not turn signs. There's plenty of signage indicating the entire road is closed. There was a lane open, probably for construction vehicles, for example. It's clear from context. Any human driver would have said, oh yeah, that road is closed, I shouldn't go there. But this robotaxi decided to go for it anyway. Fortunately, no one was hurt, but does that make this safe? I'm going to say probably this was unsafe behavior. Human drivers are imperfect. They drive drunk, they drive under the influence, they drive tired, they drive distracted. They sometimes, on occasion, aggressively violate road rules. Yeah, that's right. We all know human drivers aren't imperfect. But just because we take out the humans does not mean the robot drivers will be perfect. They're going to have their own failure modes as well, some of which are going to be the same as humans, perhaps for different reasons, and some will be uniquely inhuman failures. They're going to have software defects, and those software defects are going to cause them to misbehave. Now, we hope the number of software defects is low, but saying you have perfect software the first go just isn't a thing. It's not going to happen. There will be software defects. We have to expect them. We have to take extraordinary engineering measures to make sure that they are few in number and low in impact. These vehicles will be challenged by subtle context. Yes, there are a bunch of road closure signs, but there's a lane open. Does that mean you can drive on that lane? No, you should know from context that that's for construction vehicles, even though there's not a sign saying this lane for construction vehicles. Ordinary drivers have a lot of understanding of how the world works, and these systems based on machine learning struggle with that when they encounter a situation they haven't seen before. They're unable to reason about the missing pieces. They're also challenged by rare events for that same reason. If they see something novel, they don't know how to respond because they've never been trained to do that. There are also potential errors in building the model of the external world. If the perception and the building of the world model is inaccurate, what they think is going on isn't what's really going on. And that can lead to errors that a human driver would say, well, that's just a stupid error. That makes no sense at all. The reality behind it is there's some combination of the robot built a wrong world model because it was seeing things it didn't know how to handle, and then it responded with what it thought was the right response. But based on lack of training or lack of exposure to the scenario, it was sort of choosing an arbitrary response from its library that didn't match a situation that probably it didn't really understand. There are also potential errors by remote human operators. In this case, and this is pure speculation, it could have been that a remote operator said, oh, I see a lane, don't worry, go for it, without necessarily noticing the road was closed because of a bad camera angle or who knows what. Just because the remote operators doesn't mean they will get it perfect either. What you have is a combination of a robot that could be struggling in unusual situations, and it has to know to ask for help instead of just doing its own thing without help. And even when it asks for help, there'll be a non-zero failure rate of that remote help. All of that has to be taken into account. Now, this doesn't mean that robotaxis are necessarily more dangerous than human drivers. They might still be safer. It just means you cannot argue, well, there's no human, therefore they'll be perfect, because it's pretty clear that's not how it's going to turn out. The takeaway is that robot drivers will fail, sometimes the same but sometimes differently than human drivers.